Hi there. Let me ask you a simple question before starting. What would happen if I throw a ball in the upward direction? And we know that after some time, that ball will start coming in the downward direction. Now, why does this happen? This happens because there is an invisible force which is pulling the object in the downward direction. But who gave us the idea of that invisible force? None other than Sir Isaac Newton. We all know the story. When he was sitting under the apple tree, the apple fell on his head and he started to think as to why did this apple fall in the downward direction. After thinking for a while, he came to a conclusion that there is an invisible force which is pulling the object in the downward direction, and he named the force as the gravitational force. And that is what we'll be learning in this chapter, that is gravitation. So my name is Huzaifa and let me take you through this chapter, that is gravitation. So first of all, we'll start by understanding Newton's universal law of gravitation. Let us see the statement first. Statement says, every object in the universe attracts every other object with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Let us see the first half or the first part of the statement. It says, every object in the universe attracts every other object. This is strange, right? If this was supposed to happen, that every object attracts every other object, then all the objects would be very close to each other, right? But does this happen? No, right? That means, is this statement incorrect? No. We have understood only first half of the statement. Let us see how to understand this statement. So for this to understand, we will consider two objects of masses m1 and m2. And the distance between their centers would be denoted by small letter d or small letter r as given in the textbook. Now it says every object in the universe attracts every other object with a force. That means these two objects will attract each other with a force, and that force will be denoted by capital F, remember. It says, and this force is directly proportional to the product of their masses. We know that product means multiplication and their masses are m1 and m2. So product means m1 into m2. Now since force is directly proportional to the product of their masses, we obtain this equation or expression as F alpha m1 into m2. F means force, alpha means directly proportional, and m1 into m2 means product of their masses. Now this particular expression is of utmost importance. This expression gives us the idea as to why we get attracted towards the earth and not the objects around us. Let us try and understand. Let us take an example of a bus. In this case, I am object number 1, this bus is object number 2. I am m1, this bus is m2. So m1 into m2 will have a certain value. So our product will have a certain value. What if I am m1 and earth is m2? So the product of our masses would be much more greater than the product of me with the bus. That means we realize, since the product of our masses with the earth is way more than the objects around us, that is the reason we get attracted towards the earth and not the objects around us. Now let's move further and try and understand the second part. It says, it is inversely proportional. The force is inversely proportional to the square of the distance between their centers. The distance between their centers is denoted by small letter d. So F is not only inversely proportional to the distance, but inversely proportional to the square of the distance. So we'll write F alpha 1 upon d square and name it as equation number 2. So F alpha 1 upon d square means force is inversely proportional to the square of the distance between their centers. Now, we'll use equation 1 and 2 and we'll merge these two equations. So F remains F on the left hand side. In the numerator we write m1 into m2, and in the denominator we write upon d square. So we get F alpha m1 m2 upon d square using equation 1 and 2. But now we know that we cannot use the proportionality sign in the numericals. So we need to remove the proportionality sign and we'll use an is equal to sign. But to use an is equal to sign or to remove a proportionality sign, we need to add a constant of proportionality. So in this case, we'll use the letter capital G. So we get the formula F is equal to capital G m1 into m2 upon d square. And this becomes the formula for force of attraction, wherein capital G is called as universal constant of gravitation. So what is the formula? F is equal to capital G m1 into m2 upon d square, and this is the formula for force of attraction or force of gravitation or simply force. Now let us see how to define universal constant of gravitation using this same example. And we'll use the same formula, that is F is equal to capital G m1 into m2 upon d square. But to understand universal constant of gravitation, to define universal constant of gravitation, we'll use everything as 1. That means the masses to be 1 kg and the distance to be 1 meter. Now let's see this. We'll use m1 and m2 as 1 and even d as 1 and substitute it. So we get 1 into 1 upon 1 square, which is obviously 1. So what we obtain is F is equal to capital G. What does this mean? This means that universal constant of gravitation is equal to the force of attraction. But when is capital G equal to capital F? When we have two objects or we have two unit masses of 1 kg. When we have these two unit masses placed at unit distance apart from each other. So this is how we define it. Universal constant of gravitation is the force of attraction between two unit masses placed at unit distance apart from each other.